Hello. We will see in this tutorial how to create branched networks. And we will take as an example a small spray bar. So we are going to select from the library pipes with a diameter of 100. So we introduce a pipe with a diameter of 100 in the 3D interface. And we give it a horizontal orientation to begin with. We are going to create bifurcations in current separation. We use the create a separation function. And choose an angle of 135 degrees, which we will modify later. So that's 135 degrees. We want to create a watering ramp. It will be horizontal. We will see how to save a section and import it into the network to avoid repeating the same operations several times. So here we are going to reorient the bifurcation, so menu, adjust. You can enter the adjust menu with the enter key. Here we have adjusted horizontally, and we are going to adjust our second branch. Like that we have a first bifurcation. We are going to look at how the project tree looks. So we have our first chunk, which splits into two other chunks, which represent the branches. We are going to do a multiple branch. We will continue on this part there, and create a new fitting. We are going to readjust the branches. I select a branch, I hit the enter key to switch to adjustment mode. I adjust, and I exit adjustment mode by validating. I select. I hit the enter key to switch to adjustment mode. I reposition, and exit adjustment mode. Here we are going to model a small watering ramp. Here will be the end of the ramp, so continue after element. We give an orientation, and we leave the adjusted mode. So last, we no longer have a bifurcation, but an elbow. Now we are going to save this as small ramp, to reuse it in a more complex irrigation system. I select save. The network is registered. Okay, let's close everything. We are going to create a new network. We drag and drop a first conduit of the desired diameter. We will create a 90-degree separation. We will redirect, enter key. Selection of a grid point to designate the direction of the branch, and validate. Same thing for the other branch. So earlier, we recorded a small ramp. We are now going to insert it, insert downstream network. We have a selection window, where we choose our ramp. Here we are going to start again, and do the same thing on the other branch. Insert a downstream network. I select my little ramp number 1. We will rectify the orientations. We see here, orientators, inserted by default when importing sections, which we are going to delete. We see that the orientations are not as we would like them to be. We want them all vertical. We will take this opportunity to see how to insert an orientator. So we select the pipe, we go to the library, in the singular elements, and select the orientator element. We use the insert upstream function. We select the orientator. To simply define its orientation, we orient it at 135 degrees. That's it, we do the same for the other side. Insert the orientator upstream. I select my orientator, and I give it the orientation I want. And there you go. We have created our watering ramp. We are going to add small nozzles. We select the item here, I'm going to shrink the output. I'm going to set the output diameter to 20 mm. And insert the convergent cone. So just select this cone, and the keyboard shortcut Ctrl and C. Or in the contextual menu, copy an element, we select an element. And we can simply paste and insert our copied element downstream. So if I do Ctrl C, I copy, I select another element. I do Ctrl V and it copies. The copied cone remains in memory. So we're going to do Ctrl and V on all the other pipes to put our nozzles on the output. Here, we created a watering ramp. We just have to test the speed. I select Create a Generator. Let's say we want to test this network at 10 cubic meters an hour. This function makes it possible to create a generator, which will have sufficient pressure to generate a flow rate of 10 cubic meters per hour. So the software calculates the pressure drops, and sizes a pressure generator balancing these pressure drops at the flow rate of 10 cubic meters per hour. We're going to have fun observing the path of the particles in our network at 10 cubic meters per hour, and seeing if this sprinkler meets our expectations. So here we are in trajectory test simulation. The color of the particles corresponds to the pressure. We can follow the evolution of the pressure. We have end nozzles. The pressure is relatively balanced throughout the line. We see the ejection at the end of each nozzle. Simulated by a small ballistic trajectory of the particles. We can slow down a bit. So here we slow down on a cone. We see the evolution of the pressure, which goes from around 1700 to 0. If we can see the pressure scale. To know the pressure, we can also click on the element. And in the graph, we have the pressure in pascals. At the output, we have the atmospheric pressure, with a precision delta of 1 Pascal. Here, we exit the mode simulation of such trajectory. And we tested our spray bar. That's it for this network branching example tutorial. We'll see an upcoming tutorial on branching, looping. We will see that it is possible, under certain conditions, to join ramifications to form loops.